So hello, everybody. I think we're going to go ahead and get started. It's 4 o'clock. My name is Max Morris. I'm a Principal Program Manager in Windows, and I work in the Device and Networking Experiences team. This is Priya Dandawate, and together we've been working on the proximity experiences in Windows, and how NFC sort of powers those is the topic of this conversation today. We've got a couple of folks from our feature crew, including Travis Martin here is up front. And we've got a number of our partners that we're going to sort of talk to you today about what we've pulled together and how it all works. So let's see, where's the clicker? A little bit of last-minute technical snafus, getting things sorted out here. What we're going to go over today is looking at the proximity user model, and Priya is going to walk us through that. Some of you may have been at her talk yesterday. Who was there? Anybody? So yesterday we went through the APIs and the user model that those APIs kind of help support. We're going to recap that user model today and give that same sort of 15, 20-minute overview because we think it's really important to get you grounded in why we've come up with the model that we have and how we've integrated that into Windows. We'll segue into the programming model and give you a bit of a view about how that works, but we're not going to go over the APIs in detail. If you want to know about those, you can go learn from them, learn about them in the talk that we gave yesterday, and there's also documentation available. The bulk of the talk is going to be focused on the proximity stack and driver development, and how you, as a IHV, if you're working on a proximity solution, can bring that together, and how you, as an OEM, ought to think about what you're looking for if you're including that in your system. And then finally, some design considerations, some sort of ideas and thoughts and recommendations that we have for you to consider based on our experience with some of our partners we've been working with. And what we hope you'll be able to leave today with are some examples of really how to create a system that integrates your proximity solution to help make the cool experiences you're about to see actually work. And without further ado, I'm going to let Priya sort of drive things from here. Priya?
Perfect. Thanks so much, Max. Oh, did you want to go over the proximity solution?
Go for it. Yeah.
Great. So in terms of looking at proximity from the design and IHV OEM perspective, proximity solution integrated into Windows helps deliver a new class of experiences to users. So for those of you who were at the talk yesterday, we really modeled this new type of experiences as based on this gesture, how you interact with your devices. You tap them together. And then there's this set of inbox experiences that make it really easy to do common tasks, like share files or connect your applications together. So without any further ado, I'm going to go into the demos, which a lot of you saw yesterday, but I think they really help us get into a good mindset for how exciting proximity is and kind of how magical it is at the same moment. So I have this Nike slate up here, and as most of you know, all the slates have an NFC radio in them. And these tags have been floating around the conference that say, tap this against your build PC. We do have 1,000 of these tags. About half of them have been sorted out, but we'll have a bunch up here that you guys can come and grab after the session's over. But these tags are read-writable, and this one contains a URL. Let me show you what happens when I tap this tag against the back of the PC. You'll see I received an invitation that's inviting me to receive some content. When I accept the invitation, well, let's try that again. There we go.
That's odd.
It's very odd. Oh, I think this machine might need a hard reboot. That's interesting.
Why are you having a hard time?
I think the applications in general are just having a hard time.
Okay, why don't you do it on this one?
Sure.
Swap over.
We can definitely swap over to this machine.
I got it. Go ahead. Go ahead.
Great. So when I tap this against the back of the PC, you'll see if I receive the same toast, which is good information. And, oh, it looks like these are giving us a hard time right now.
Uh-oh.
This might be a demo snafu. Well, what'll happen is I will accept the invitation, and then it'll launch the Metro browser, which will open up the Build Windows website. So that's a really, really cool, magical experience, because at some level, Windows knows exactly what to do with that tag, that information. And from the tags perspective, it holds the Windows build site. And those tags I mentioned to you, they are read-writable, so you can put other types of information there as well, such as mail to, and it would open up an email client, and you can actually insert your own email address in there. And you can kind of filter around your, maybe your business card, or you could filter around your website that's promoting yourself or your business, or you can even launch an app as well. So the other cool thing, I'm going to let these guys sort out the demo gremlins, whatever they are going on in there, but I'll talk about a little bit more about the experiences that we've built in Box. The cool thing is I can actually share that website from my Windows 8 slate to Macs without having to hand them the tag. So I'm sure a lot of you have been there where you're in a meeting room, you want to share a URL link with someone else, and you literally have to email that person who's sitting right next to you that email, that URL link, which is just very archaic. It's heavy. I mean, or you could spell it out for them, which seems even worse. But with the Windows 8 proximity experiences, what we allow you to do in a very consistent way is invoke our charms, choose the device's charm, then choose an option that says someone nearby, and then we'll go ahead, when the tap occurs, transfer that content from one device to another. And on the receive side, you'll see the same exact toast that you saw when I tapped the tag against the back of the machine, inviting my friend to launch the content. So it's a very, very consistent user experience, whether you're sending content or receiving content. And from an API perspective, the way we've built in that in-box NFC sharing functionality is we've taken care of all the UI work, and all you have to do in terms of an application developer is tell us what you want to send at the time of a tap. So that's really our sharing in-box experiences that we find super compelling, that we did a lot of usability research on, and it looks like that was one of the things that users really wanted to do. So from there, there's another tag up here that shows how to launch a website or launch an application, which is really interesting when you think about virally distributing your apps from different places. So you could actually put up a whole wall of tags and be able to tap against all of them and be able to launch an application. Or we actually, if that application isn't installed in your machine, we'll invite you to acquire it from the store as well. So we're very much centered around this model of people getting applications through proximity and people interacting not only with other people, but also with their environment. And last thing, that's one of our demos that hopefully we'll be able to show you guys in a few minutes, is being able to connect two instances of the same application using our networking stack. And when I say networking stack, it kind of scares some people because you think that, oh, we're going to be showing you all about the radios, we're going to show you about these sockets that are getting connected, but none of that is what's shown at the UI layer. We really want to keep our application experiences all about two people sharing something together. So what happens is it's an app our interns built. It's really, really cool. It's called Bitbox, and it's all about making your own beats and being able to DJ. So in the app itself, I can make my own beats, tap against Max, and then he'll receive an invitation to launch that app, and then he can make his own beats, and from there we can go into a collaborative DJ session where I would be the controller and he would be the client. So you can see, like, I am actually very passionate about music, so being able to have this application where I can invite Max into my world of music and my world of applications that revolve around music, it's pretty cool. And a lot of our experiences and the demos that hopefully we'll be able to show you guys are focused around people to people and me and my environment. And that's really what proximity is all about. It's about users being able to connect with other users through their devices. It's a very people-centric model. And so the reason why we did this is because we find when we were reimagining Windows 8, we wanted devices to really speak a lot about the users themselves. So we took this feedback, we took these new set of experiences to the lab to see what our users thought about that. So I want to show you guys a quick video about what our users think about these new proximity experiences and this new way of interacting with devices.
It's you're transferring data. That's like, it's amazing. Because it used to be you used to have to connect all kinds of wires and everything.
That's great. It's taking it's actually making devices human again. You know, it's like where you can actually interact with people with your device. I think that's great because devices have become so, you know, we're all on the network, and you know, and we all must, you know, conform. Where now I can have my own device and I can share with you what I want by tapping or bumping or whatever you want to call it. And now it makes it more of a human approach.
I thought it was pretty neat. I mean, just to tap it. I mean, I've never heard of that before, so I thought that was pretty neat.
But it'd be kind of cool if we're like in the same proximity, and I could just tap, boom, and it's like, hey, do you want to share, you know, photos? And then we could actually share, and I'll say, hey, yeah, I want to share these, boom, and we can tap. So I think there's all kinds of different, the more content that people acquire, the more they'll want to share it.
Saying that that's some really, really exciting stuff. Seeing how excited users are about this new innovative way of interacting with your devices, it gets you excited as well because they see how natural this gesture is, which is why we really relate this new user model of tapping devices together to a handshake. Because when you think about a handshake, you physically do touch someone for a couple of seconds, and it's usually the start of something else. And so that's the same way we've built our model, which is very much tap and go. We want to tap, go, and start something else. And we'll facilitate that discussion over some other transports, which Max will get into in just a couple minutes. But when you think about it, it's kind of a new way of interacting with devices, right? Like, it's not common for me to tap my device against anything. And so this new kind of natural way of being able to use your device, that was another piece of feedback that we got from users in labs as well. So I want to show you guys another video that relates more about that gesture. It's pretty fun. All right.
Tap and send. To begin, tap devices near the sensor. Okay. That's hilarious. It's like they're kissing. That is cool.
No, it's really cool in between things, home networks and stuff.
Yeah.
It's easier than, it replaces Dropbox. Alright, tap me.
Oh.
Tap that.
Devices near the NFC sensor, so.
Let's see how close.
Yeah, it's not seeing it yet.
Yeah.
One tap.
Is it just a quick tap and then we can put it back down, or do we need to hold it up?
That's like maintaining the personal contact in electronic communication. It's the high five of.
What do you think of that?
I think it's weird.
Okay.
We haven't fully explored its capabilities yet. So far, I think it's weird.
Let's get married.
I can't wait to see what that is.
That was awkward.
So
Okay.
I would find it amusing to do that, especially like I could see being at my house with my wife and have pictures on my computer that I want to show her or something, or on my, like you say, your phone. Like, hey, babe, check this picture that I got today. Just tap her computer and they go on there.
So those videos are pretty entertaining to say the least. But what you find is that you get a lot of those guys, they got a really emotional reaction by tapping devices together. And you don't really see that with any other interaction that you have with your PCs. And so when we talked to our application developers yesterday about what type of apps you can go out there and build, we really wanted to make that point that you can make this application really resonate with the human element that's there in proximity. The fact that we see devices as an extension of ourselves. You know, devices hold our photos, they hold our media, they hold emails, resumes, documents. That's really a part of ourselves that's in that device. And so when you tap it against someone else's device, you do feel that human element right there. Which goes into like which ties really well into our complete story for our user model, because we've talked about a couple different elements here, that this is a new way of interacting with devices that's not just about radio layers or networking, it's about people. It's about me being close with my environment and me being close with other people. And really that tap model is to start a discussion over something else. So we want to really resonate that idea of it's tap and go. And with that, I want to show you guys the demos.
Yeah, so what's going on is, what's going on is that we've got the wrong resolution for our screens, and so Metro-style apps won't launch. So that's not going to be very helpful. So we're not going to be able to show you the demo, but we're going to actually do it up here, and you can see how excited we're going to be about making it work. So I'm going to narrate while it's Priya. Go ahead.
Sure.
Maybe the camera guy can zoom in a bit, so at least the people who are looking at this online will kind of get a glimpse. Go ahead, Priya.
Sure. So I'm going to tap this card against the back of the PC. You see there's a toast that comes up that's inviting me to receive content. When I accept the toast, this time Internet Explorer does launch, and it contains the build website.
It's pretty cool. All right, so now let's go ahead and, Priya, I'd like to get a hold of that website too.
That's great. Well, Max, I can do that with proximity.
So why don't you tell us how you do that?
Sure. So I'm going to go ahead and swipe in and choose the devices charm. You'll see there's an option here that says someone nearby. I'm going to go ahead and accept for someone nearby, and now I receive a prompt that's telling me to tap these devices together.
All right, let's tap together. So I immediately get a notification that says I'm invited to open that website as well, and there's the build website. So just like that, the URL was transferred between machines, pretty simple, lightweight, tap and go.
Yeah, exactly.
So you want to talk a little bit about musics, or do we want to just move right into the next thing?
Well, I wanted to actually stop for just a moment and talk to you about that user model that we just showed off. You saw that there was an invitation that just popped up inviting me to receive content. And that's, at one level, lets the user feel like they're in control of that experience, right? Like Max, it didn't just interrupt him completely and pull him away from his current experience. He was just very slightly tapped on the shoulder like, hey, there's something here that you can check out if you'd like to. So now I'm going to show you what the app our interns built. This is another tag that launches the app, which is called Bitbox. So I'm going to tap this to the back of the machine. Wait, excuse me.
Don't drop it.
Yeah. And so when I launch this, you can see Bitbox, which all of you have as well.
And you can all do this at home. You've got these apps, and we're going to give you some of these cards.
Yep. And so now I'm going to choose to host a session so that Max and I can go into a collaborative DJ session together. And on the screen, it's telling me to tap a friend to invite to play together.
But first, you're going to make some music, or are you making music?
No, I'll wait till we've connected, and then I'll make some music.
Okay, so I'm ready to get connected. We do a bit of a tap. This one takes a little bit more time to connect.
Mm-hmm.
Is it working?
No, not yet.
We're having this.
Oh, here we go, here we go.
Oh.
Connecting as host, successfully
Awesome.
connected.
Okay. Finally, Bitbox is working. And so wave that up and show people.
Oh, yeah, sorry. I forgot.
So that's a controller. She's controlling me, which is pretty typical in the way that we get along. And so I'm going to start making a little bit of music, and then you're going to see that she's going to be able to mute me. So I'm going to put down a bit of a bass track.
And I will put down.
So I'm going to try to yank up the volume so you can all hear it. Yeah, I guess we could plug in our audio a little bit, or if we could figure out where it is. Yeah, the audio has not got a resolution problem. Well, that's not working either. We're done. We're done with the cables. Cable free and fancy free. All right. So I'm going to put in a couple of other things. Let's see. I've got some drums I'm going to put in there.
And you guys can't hear it, but it's actually playing from my machine right here. Both are machines.
So I'm going to go ahead and mute mine, and now you can hear that she's.
But I don't like what he's playing, so I'm going to stop that. And
Darn.
Now I'm just playing what's on my machine.
So here's two apps connected together with a socket, effectively, that we exchange. There's a session key that the app developer could pick up and use. And it's laid down in this instance with Bluetooth because Wi-Fi in this environment doesn't route with peer-to-peer. And so we wanted to go with a peer-to-peer routing protocol. We have Wi-Fi Direct built in to these tablets as well. but it takes quite a while to connect, and that's part of what you saw here is some of our connection protocols. We need to do some optimization work, obviously, still. But we're working on that. Plus, our interns, while they did a fantastic job on these apps, we're not quite sure what they've got going on in here. So, but you saw it working. That's pretty cool. Let me talk a little bit about the tablets that you all have. Many of you folks are, thanks Priya.
Yeah.
Many of you folks are working on hardware, and either you're an IHV or you're an OEM, PC system maker. We've done a partnership here with Samsung to build these developer preview systems, and also with NXP. They've put a radio in and also a driver that meets a lot of the specifications that we're going to talk to you today about. And we're pretty happy about it. I think in your package, you will have gotten information about a microsite that gives you more information about how the radio works, where the antenna is placed, how to deal with the driver if it goes off its course a little bit, which it may do sometimes because, again, we're in developer preview mode. We are servicing this box, and so periodically you may get some updates with further improvements. For example, some of the gremlins might go away, either in our stack or in the driver. And also, there's going to be more interoperability that you're going to be seeing in terms of what the protocols that are spoken over the air interface. So keep looking forward to that. And also, the folks at NXP have got other information for you. We've got a couple of them here if you want to talk to them, if you're interested in knowing what they've done. We're working with other partners as well in this area, both in terms of OEMs and system makers as well as IHVs. So, but this is what you've got your hands on today. So with that, happy we were able to at least show you some idea of the demo and the fact that we could kind of make these things work. Let me talk a little bit about the programming model briefly, because I want to kind of catch up on some of our time. One of the things you saw here in these tap and go experiences across a number of them, whether it's send and receive messages, connecting apps together, i.e. using that share contract or setting up a device, which we didn't show here today, but was demonstrated earlier today, where you can tap a Bluetooth mouse and actually get that installed very seamlessly with just one tap. These are things that really all share a common pattern. These experiences, it turned out, really have this notion of very simple, repeatable kind of steps. And what we've done in our programming model is we've taken this user experience construct and we've mapped it into a programming construct. And we now have that pattern so that app developers can really focus on that experience. So as a construct, tap and go really is about anticipating user intent first, setting up context, and then triggering actions to actually actuate that context. So this common tap and go pattern really is about user figuring out what's going on, because there's a lot of things that can go on the PC. You might be in one app, you might be in another app, you might be looking at this thing, you might be looking at that thing. So with the user and the developer and Windows, we're effectively figuring out the context that the user's intent is sort of targeted at for that tap action. Sometimes there's multiple things that could be done, because I might be looking at something, but I might tap my mouse at the same time. So we've got to kind of tease that apart. But when that tap occurs, we actually have it set up to be very definitive in terms of what triggering action to take. Tap and go, in the way that we've modeled it in our programming construct, and you'll see this in our APIs, is not about talking machine language down to the radio. It's not a networking stack. It's not a low-level interface. Windows and the proximity solution really work together to make that happen. And that's really what we want to talk about now, is how between the driver and the hardware and Windows, this programming model is actually enabled for Metro-style app devs. I'm going to make a note here. We're talking about NFC today, but you'll also hear us use the word proximity. The way that we've modeled this in Windows is that the app developer doesn't know that it's NFC. They can, if they'd like to. They can tunnel down, they can provide some specific structures, but we're not making an NFC API. This is a tap and go API. And yet, at the same time, NFC is very important because it really is the leading proximity technology out there. There are other ones out there. Windows is an open platform. There are a lot of opportunities, and when you take a look at the driver interface, you'll see that there are options for other technologies. But we're getting behind NFC because it really provides a compatibility baseline to enable users to interact for these tap-and-go scenarios. So we're big advocates of it, and we're advocating that to you, and it's really how we're focusing on taking this to market. Let me talk a little bit about our architecture. And you'll see in many of the sessions this week that architecture slides are very much at a more abstract level. It's difficult to really get into all the details of what we've done in just a brief hour's worth of time. So you'll be able to see more information about our design and the driver model in documentation that you can get later. At the top level, you see in blue those Metro-style apps. And these are just Metro-style apps that are using the proximity APIs that I've briefly mentioned. In the middle, you can see that there are a couple of components that are involved. When the app is deployed, it's made known to Windows in terms of an installed app list. And this is how we know about its identity and its availability in the system. Then we have a proximity API. And it's really between these two components that apps interact. In Windows, we have a pairing experience, which some of you may have seen earlier today. And it's a lot of words, but really what happens is you take a mouse and you tap it to the PC, and it just gets set up. That's all it is. There's a toast or a notification that asks the user whether you want to use the mouse, and that's it. Everything else happens under the covers. That's the pairing experience. You just saw earlier, as best as we could show you, unfortunately, the proximity pairing, the sharing experience. You'll be able to play with that with your Samsung devices right now. Find a URL, go to the devices charm, choose someone nearby, and find a friend and try it. Supporting all of these functionality on the proximity side is a proximity service that we have running. And we use this service to really facilitate interactions in terms of launching apps, being able to help apps and the API interact with the underlying driver. And it's basically sitting there as a set of functions that help Windows kind of keep things going. And for out-of-band transports for peer-to-peer sessions, like you saw with that Bitbox app, when you got connected, Bitbox got connected over a socket on the Bluetooth transport in that instance. Or it might have been Wi-Fi direct. No, it wasn't. It was Bluetooth for sure. So we turned off Wi-Fi. And so with the firewall service, one of the things that's very important is for us to be able to provide a secure path between the lowest level of that networking interface all the way up to the application, so that we can maintain the integrity of the security of the app container environment that the Metro-style app lives in. And then there in red, right next to the networking drivers and the networking access devices layer, are proximity driver and a proximity device. And we're going to spend some time now talking about what that driver model looks like. We've introduced a new device interface class. It's GUID Device Interface NFP, stands for Near Field Proximity. It's kind of our attempt at blending the concept of NFC and proximity generally to have kind of an open model, but really geared towards NFC as our leading technology. There's 9 new ioctals that we've defined, and we use these ioctals on handles, and I'll talk about an example in an abstract way about how that works. This driver model itself models the tap and go gesture at the device level. And the way that we're doing this is that we've effectively modeled a state machine inside the driver that handles pub sub as a programming construct. That's the pattern that we're using. Speaking about pub sub, developers classify messages into namespaces for routing. So this is sort of like tuning into a frequency that someone else is broadcasting on for people who aren't familiar with the pub sub model. But effectively, there's a publication and a subscription, and if I'm publishing something that you're subscribing to, those things get matched when the devices tap. And in a sense, the way that we're doing this in the driver model is that each publication and subscription is a unique open handle down to the driver. The open handle is handled by the proximity API, so apps don't need to deal with this. The API is talking through the stack down to the driver. And one way from the driver perspective to understand this is that messages are really kind of a collection of reads and writes hanging out there in the driver. And the driver's pending that collection, sort of just waiting until a match is made when a tap occurs. And that's really the best way to describe the model. And when that tap occurs, the driver does a couple of things. First, it sends out active publications. And when it does that, if there is anyone listening, then it actually sends up a notification to the sender or the publisher that the message was transmitted. And if anything comes in that matches a subscription that is currently active in the state table, then the driver will then go ahead and send that up to the subscriber, effectively notifying them. How does Windows 8 use the proximity driver? Well, in effect, while we have an abstract model for how this driver works, we're actually using it quite a bit. I've listed here the active publications and subscriptions that Windows itself has. You saw some of those green boxes I showed you earlier. We're modeling the arrival and departure of another proximate device with subscription. This allows us to do things like play the sound, know about enveloping, be able to communicate to the developer when the event is actually occurring. We have some subscriptions for pairing devices over wireless transports. We have support for Bluetooth and Wi-Fi Direct. We have subscriptions and publications to help initiate the peer-to-peer session, which I'll talk about a little bit later. And we also have subscriptions for URIs. That's what you saw earlier. And right now for MIME content. At the moment, we're not doing anything with the MIME content subscription, but we expect to be doing something with that later. And then also with sleep or lock screen events, when the machine goes to sleep or wakes up, or if the screen gets locked or gets unlocked, our service sends an IOTL down to the driver to essentially enable or disable publication. And of course, on resume, the disable or the enable event is sent down. And this, in effect, allows the driver to essentially know, okay, I need to kind of wrap things up in the moment, or, oh, it's all ready to go again, without having to refresh all the state from all the apps, including Windows that may be active. How proximity drivers use NFC. The drivers themselves implement the NFC forum protocols for interop. Windows itself doesn't. For folks who aren't familiar with NFC itself, these Windows messages are packaged in the driver into an INDEF format. It may be that the developer at the top level in a Metro-style app has provided that INDEF format already, in which case there's no repackaging that's required. So we do give a raw access up to the app devs if they want that. INDEF is an NFC data exchange format. It's just a packaging format. It's really kind of down to the binary level. And in PC-to-PC cases, we use SNEP for multi-message exchange. This is a new standard that was just ratified. The driver version that you have right now does not implement SNEP. The one that you're going to get pretty shortly does. We're pretty behind standards, and we're really excited that SNEP has gotten ratified because it gives a common interop basis between vendors and between systems, including non-Windows systems, to support the message flow. And so in this case, SNEP is Simple INDEF Message Exchange Protocol, and it runs over LCP, which is another protocol. LCP is a logical link layer protocol that effectively runs over a peer-to-peer transport at a very, very low link that the NFC radios themselves get into when they detect another peer is around. And there's a number of primers out there for folks who are getting kind of into the world of NFC. Because between passive tags and active tags and peer-to-peer, there's lots of different ways that that radio can run. There's another case, which you saw some demonstration of here, which is tag reading. We also support tag writing. And in these cases, we just basically write INDEF messages directly or read INDEF messages directly. So I gave you a lot of text, a lot of concepts here. Thought it would be useful, rather than jumping into code and showing all sorts of IOCTLs, to give a bit of a walkthrough about how these layers interact. I'm going to, in this discussion, pretend that Windows isn't doing anything, because it kind of will give you a sense of how the driver goes from quiescence to being very involved, and the device very involved, to now back to quiescence. So we can kind of see very abstractly how everything goes from nothing to a lot to nothing. So in this case, the abstract machine on the right, as you can see, is going to subscribe to a message. Here we have an app. It's just calling the API, which is subscribe. We have a very simple 3 lines of code required to do that in JavaScript. You get the default device. You take the value that you want to publish and you put it down there on the namespace of interest that you want someone else to tune into, and you probably ought to let the user know that you're ready to tap. That's all the code is required. The Proximity API takes that and does a number of things. It opens up a handle down into the driver, and it sends a new ioctl down, which is effectively, I want to subscribe to the next message, in a sense. Let me know when something's going on, so that it knows, the app can know, when something has actually been delivered or received. And then it pens the octal down in the driver is where that happens. And so now with the ioctl pended, and the driver can then go down and talk to the device and say, device, it's time to get going. And so at this point in time, again, speaking very abstractly, the device can begin polling. Up until then, it doesn't need to do anything. So now polling can begin. And this machine is sort of ready to tap. Let's take a look at the other machine. This machine is now publishing a message. The flow looks very similar. Our API is very similar. It's get the default device, publish a message, hopefully on the same namespace in this example, and let the user know. Similarly, the API then opens up a handle down to the driver, sends the ioctl down, which is the payload. In this case, there's actually a message to move, and so it sends the buffer down. There's another ioctl, which is get transmitted message, so let me know when something has been done. And then that ioctl gets pended in the driver. And as the driver then has that, it then speaks down to its device and says, hey, device, begin polling. So now we have both devices set up. Both of them are polling. One has a subscription. One has a publication. Both of these are active. The rest of the system is pretty quiet. The driver is going. A tap occurs. And at that moment, in that exchange, very quickly, peer-to-peer NFC is negotiated because both devices are active participants. SNEP is run over LCP, so we bring up LCP, we bring up SNEP, and hello. Message is sent over SNEP, and that's it. That's the tap. And so you saw that earlier when we moved the URL from one machine to the next. When receiving that message, the device passes that up to the driver. Notice that the device is still polling. It hasn't been told to not poll anymore. The driver goes ahead and fills the pended buffer, and it completes the ioctl, which is the ask for the next one. And technically speaking, it gets passed up to the app at that point in time, and then the app turns around on the API and immediately tells the device, or tells the API to pend a new ioctl. I'm simplifying that here just for the sake of discussion. So a new ioctl is immediately pended. The message has been received, and we're now still back to the point where the app is still subscribing to the message. Because you'll see that subscription and transmission, they're different models. So now we actually have to, this clicker's not working, stop the subscription if the app no longer wants to get anything on that subscription. So it just closes it down. The Proximity then API then calls down to the driver to cancel I/O, closes the handle. Driver complies and lets the device know that it's time to just stop and go back to being quiet. Similarly, on the receive side, the flow is just exactly the same. The message is sent. There's no buffer to pass up now. The confirmation is sent to the driver. The driver lets the API know that the completion has occurred. The driver still has the message in its table and hasn't gotten rid of it because it hasn't been asked to go anywhere. A new ioctl is pended, again, using that kind of complex dance I said a minute ago between the app, the API, and the driver. And the message sent confirmation is then sent up to the app. So now we've successfully moved the message from one end to the other. We've gotten confirmations from one end to the other. Everybody knows what's going on. Subscription has been stopped on the other side. Now I'm going to stop listening, or stop sending the message. So I have to stop the publication. Notice that the driver is still pending. It's got a pended ioctl. The device is still polling. The app at this point decides to stop publishing. The API calls cancel I/O, closes the handle. Driver complies, lets the device know that it's time to stop polling. And so in a nutshell, you see how the model that we have works between an app, Proximity API, the device driver, and the NFC hardware. And with this model, we are effectively able to do all the scenarios that you're seeing and many more. Now let me talk about how Windows, and not the driver and not the device, but how Windows sets up a peer-to-peer session. Windows uses NFC to kickstart a peer-to-peer session. And it uses the model that you just saw, plus the networking stacks in our firewall service, to do quite a few things. As I mentioned earlier, Windows has a number of active subscriptions and publications, essentially always set up to listen for or to provide a session on behalf of higher level components in Windows, such as the sharing experience, or apps that are using the proximity API. So when a session is actually requested, and the proximity API knows about this, then during the tap, Windows exchanges peer information and connectivity information. The peer information includes things like app identity and the namespace of the Windows store. So it's an important point I'm making here, which is that the protocol mechanism that we have defined supports other systems. We've designed it to be open and interoperable. The connectivity info is also such information as MAC addresses, state information about Bluetooth or Wi-Fi or Wi-Fi Direct, or basically any kind of TCP/IP connectivity available that might map into a socket. During the tap, Windows also negotiates, using a Diffie-Hellman-like algorithm, a session key. And it is able to then provide the session key up to an app dev in a Metro-style app to be used if the app would like. It's just effectively a service that's available. This happens relatively quickly. We think that it takes on the order of a couple hundred milliseconds on a typical NFC connection that's full performance. So we've got it down to a pretty small size. With polling intervals and being able to kick things up, we believe that we're going to be able to get this down to a sub-second easily, and maybe even down to sub-0.7 seconds. After the tap, a number of things happen. If the app is not installed, then Windows invites the user on the other end to get the app if they like. And it opens up the store and navigates to the page for the app. And so if I, for example, didn't have Bitbox installed and Priya wanted to play Bitbox with me, then I would be invited to the store to go get Bitbox. If the app isn't in the foreground but it is installed, then Windows will go ahead and invite the user to switch. And you'll see a toast, and then I can move over to basically to the app. And so through a simple toasting model, the user is able to get into the right context if that context wasn't available. At the same time while all of this is happening, Windows has proceeded in initiating all the matching transports that may have been determined mutually through the connectivity info exchange. So we fire up Bluetooth, we fire up Wi-Fi Direct, we fire up Wi-Fi, we fire up IP. Anything we can find, we fire up right away. And we try to connect. And we use an algorithm that includes time to connect, bandwidth, and overall capacity in the system in terms of resources. And we effectively then determine very quickly what the best socket to use is, and we hand that up to the app. So that by the time the app is either in context because it's been launched, or the app has presented its own UI, which we think is within a few seconds, the app really has a socket and is ready to go. And so that's how the model works, and that's why we can do tap and go. You'll notice in this model that it's not a very complex negotiation post-tap. It's very much pre-tap, where everything has been set up contextually. And this allows the action to not bleed into a very complex user interface. So let me move on to a few design considerations, and then we'll wrap it up and take some questions. On the device driver engineering side, whether it's you as an IHV or if it's you as an OEM, a couple things to keep in mind. These aren't things you must do, but they're things that we like you to think about. The UMDF driver model will work fine for performance. You don't need to do something in KMDF. KMDF is hard, it's complicated. UMDF is easier. I won't say it's easy, but it's certainly easier. And it works fine. So we really recommend it. As I mentioned earlier, Please don't pull in the driver, pull down on the hardware. You'll really kind of battle performance issues if you do the pulling up at the driver layer. The app and Windows want to know when another device is present or not. And so the way that you can respond to the subscription for presence is really to detect field and immediately inform that out through your driver. So you probably need a special path for that. When you get an enable or disable IOTL on the publications or subscriptions, you don't need to flush the state from your state machine. Just store it, because when we come back, we'll either ask you to restore it or not, and it would be just easier and faster for you to just have it. And battery impact. We're all working together to have a much, much better systems in terms of battery performance and lifetime for the battery. So we have a number of suggestions and recommendations for all drivers, and these drivers included, for how to think about power, how to think about managing the radio. The nice thing is that the NFC radio itself doesn't consume a lot of power, and so it's really about being very careful and considerate in the driver design. And it's hard, but it's something to really pay attention to. I call these user experience considerations because, as you saw, proximity really is about the user interacting with a device to interact with another person. It's using the device as an extension of his self or herself. And so it's really about how the man-machine interface of something like this works. Putting the antenna here doesn't help when I want to do that. So, and it's really important to think about what it means to do this kind of interaction, because we think these are going to get light, simple, they're not going to be hot, people are going to use them, they're going to have phones, they're going to have other devices. We want the model, you want the model to be simple so we can get adoption of these scenarios. So think about the scenarios that we were talking about and showing earlier when you take a look at this list. We think the antenna going in the upper right-hand quadrant on the back of the tablet is a pretty good place. From our user research, we found that that seems to be the place that most people, right-handed people, would want to go. Keeps your hands out of the way, it allows the tap to occur. This particular antenna happens to be a little bit lower than I think we'd prefer, but it's great that it's there and that it works as well as it does. We're pretty happy with it. We're establishing some touch mark guidelines. It's pretty hard to know where to tap, so we're looking at some graphics that are pretty lightweight and low impact for how to help the user guide where it is. Antenna size, to get the effective range that we're looking for, it's really about a 3 by 5 centimeter antenna. It's not small, and that's challenging, we know, but it's also, helping enable some pretty compelling scenarios. So there's a trade-off in design that you have to consider here. It's a bit of an obvious point, but I want to put it in here as well because there's a lot of engineering that can be done around this. A ferrite shield behind the antenna can minimize interference. There's a lot of approaches about how to creating a very thin ferrite shield to help achieve goals that you may have in creating a very, very thin system. It doesn't have to be the ferrite shields that you may think that you have to use. There's a lot of options out there, so please look into those. And finally, again, I made the point earlier, we know that a lot of folks are interested in using a metal back on slates and tablets, and we really respect that from a design point of view. It's very difficult, of course, to almost impossible, actually, to have an NFC antenna and a metal back. And so there are some compromises that need to be looked at if you go for a really rigid design with metal backing, either a cutout, maybe a logo, other types of mechanisms like honeycombing or fiberglass to achieve rigidity. Those drive up costs, certainly, but they also help deliver on those cool scenarios that we were seeing earlier. Last, a few points. There's a bunch of work that we've done with folks in the industry around simple peripheral buses, whether it's I2C or SPI or high-speed UART. Please take a look at using those in your systems, especially if you're going for an always-on, always-connected device or a SoC-type system. They really will help minimize power drain, and we have support to help you to figure out how to do that. If you must use USB in your design, please be very careful with it, and especially support selective suspend to save power. And last, stop pulling on the hardware when no active pubs or subs are there. We think that will be uncommon, but there will be cases for where that's going to be important, so please be mindful of that. Last thing I want to make a note of, we have some certification guidelines and some test collateral that we've put together and that we're working on that will really help you achieve the kind of user experience that we think people are going to love. And they're designed to help you and designed to guide you in terms of your design. So please take a look at them and consider using them in your implementation. So let me wrap it up. Proximity solution integrated into Windows really helps deliver a new class of experiences to users. We can't make those scenarios work without your help and without your focus and attention on some of the things that I've been talking about. And so together we can really light those scenarios up for app developers and for users. The platform that we've developed and the designs that we have really can enable a new class of apps, we believe. You can integrate your solution into your system that enables that experience to get delivered to users. And we have things to work that you can use to help test your system and to make it work great. There are a number of other sessions that we have going on. Some of these have already occurred, but they're all online, and you can go up and take a listen to them. Some of them are still coming up. And so please take a look at them and see and attend what you can. This session itself will also be online, and you can go and take a look at some of the slides and some of the other things that we've talked about earlier. And then finally, we're going to be releasing more and more information. We have a document coming out soon on how the driver model works itself, the documentation layer for it. Their sample is already available in the WDK with a sample driver and an implementation of it. And also, there's a forum up there. Please reference the session 269. Our team is really excited to work with you. We've got a partner engagement team, we've got support staff, and the folks on my feature crew are really excited to work with you, ask any questions we can answer, and any kind of guidance we can give, because we want to really help you be successful in delivering on these scenarios with us. So with that, thank you very much. We'll take questions up here, and we'll also have some tags that we can hand out. And also, in just the next half hour or so, the Ask the Expert session will be on, and Priya and I and Travis and others from the team will be there, and we're happy to go into even further detail with you if you'd like. So thanks very much.